In this video, I'm going to create one app function. So let's start with create. We can give anything analog, analog test true. Okay. In previous video, we discussed type of sensor, analog sensors, type of analog sensors. Uh, I have given one formula there how to calculate theoretically the value of analog output. Uh, so in this video, we are going to develop block for analog sensor, and uh, as a person, we can write a different logic for a same program. Means same program. Okay. So first of all, we add one controller for our this is TI portal view. We are going to add a 1500 CPU. We will use 1512C 1PN. So here we get the information about article number, version, and lots of information: how many input, how many outputs, and which how many Profinet port, uh, uh, the communication which is suitable for this device, UPC, OPC, UA, client server, web server. The description is given here. Okay, so we have selected our controller. Once we selected our controller, we are going to create one block. It is taking time. I don't know why. Come on. So the block we are going to use is a scale block. For analog sensor in Siemens TI portal, we use two blocks. One is normalize function and another normalize, and another is scale X and norm X. So we can use as a scale X. We use only scale for analog sensor. So we have selected our controller. We can see the property of controller over here in the property section. So 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 here is the input output. We have, you can see that we have almost 1, 2, 3, 4, 5. Now we have five analog input. So for first one, you go to tag table, PLC tag here. Then you create one tag table. You can rename that as analog, analog, analog. You can just say it analog, analog tags. Keep it analog tag, and then go here. Okay, and this uh, give temperature, temperature. Okay, and here. Okay, Right. Okay. Okay. The first tag is temperature. Whenever you go here in property, in property list, you see analog in a tag table of analog tag and the, okay, you got it. Now in our program we use this. So go to add new block and we create one function. We can call that function as a analog 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 sensor only. Sorry, I misspelled sir. Okay. Uh, if you're using once only in whole program, if you have one analog sensor in your program, then you don't need to create FC, means a function. If you have multiple analog sensor in your program, then and then only you need a FC. So you just drag and drop that function in your program whenever you need it. Okay, this is the standardized function. So here we call the scale block. What we need scale. Which is so let's create input output. First of all, we have a analog sensor input. So I of W because it is in word. So we can name it at analog input. Okay, input PV. You can call it as a PV, and the data type will be int. Okay, then we have a range. What we have I of W because it's also in this may be in a real value or okay. So we have analog. Uh, we can call min minimum PV. Okay, and here we have another tag max PV. Okay. Mm, then in output, go to the block. Just look at the block. What we have this function. So bipolar is also a tag, and the tag is in bull. Data type is bull. So use as a X bipolar. Okay, and the data type will be bull. In output, we have I of X of X return value or it is in int form, int data type, and the output I you have, because we are using in sorry my bad q of x and q of w analog output output p of v. Okay, this is in real because we are getting into 0 to 100 format mostly. Okay, then first we assign our tags. Just do drag and drop. So we have created our block. Now we are going to call that block in our program. So right now I don't have big program, so I just call into main. So we have one temperature. We are given the minimum is 0 and maximum will be 100. We don't have a bipolar, so we keep it as a 0. So we need to create two tags here. So I will go into default tag table, or you can just create here also, but I will keep it in separate block. So default tag table, we create a we can give that as a global variable. So right, okay, and assign as define tag that as a local variable and define. Okay, we just assign a local variable. So because we need it only in program, so we are not going to assign to any HMI tag here in HMI, but this is this tag we need in our HMI. So we'll take that in MW 0 0. Okay, uh, and we rename as the value of temperature we are going to get into 0 to 100 form. So the thing it is getting into Kelvin. Okay, it's for Kelvin or in degree Celsius, so we keep it as a Kelvin temp. Okay, done. Then oh, why it is not taking the data I got actual parameter does not match the form. I no MW 0. What happened to okay, and here is MW we are using. Okay, so we have prepared our block. We save that project and compile our project. There is an error. Just give me 1 minute. I will do. So the compilation is completed and we can go online. I know the video is going bit little bit longer, but I just want to show you the simulation. So whatever your queries get clear. It take time. Now we are online. You can check that. Let's give one value here as an analog sensor. Give 15. Okay, this is in hexa. Sorry, 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 sorry. Okay, just give me 1 second to check that. So here's the one issue because I don't have a physical analog input or a analog sensor connected to my device. So the thing is, I cannot put any value here. So I have to do the forceful thing, and I force that value to 15,000. So right now it is 15,000, and what I'm getting is 54. If I do okay, if I do